Hi, fourth graders. This is Mrs. Smith going over your mountain math questions. Today, if you are following along with our schedule, is May 4th, and you are responsible for questions 1 through 3. So question 1 takes up the entire front page. You're using these two numbers to help you. And then questions 2 and 3 are on the back. This is question 2, and this is question 3. Questions 4 and 5 you will do, I believe the date is May 8th. Okay, so we are just going over questions 1 through 3 in this video. The hope is that if you're watching this video, you've already completed this worksheet to the best of your ability, and then you are using this worksheet to help check your answers and double check the ones that maybe you weren't sure about. So I'm going to go through this, and then if you have more specific questions, make sure to reach out and let me know which ones you weren't quite sure about, and I can help you go through those in more detail. All right, so here's question 1. I'm going to write the first number and the second number in both of these top boxes. So I have 676 and 667 according to up here. Okay, now I need to decide if both of these numbers are even or odd. When we determine if a number is even or odd, we look at the digit in the ones place. So in this number, 676, this 6 here is in the ones place. I know 6 is an even number, so this entire number, 676, is even because the digit in the ones place is even. Now I told you that I know 6 is an even number. And the reason I know that is because if I show you 6 things, even numbers always have a buddy. And you can see here are my 6 dots, and they all have a buddy. So 676 is even. Okay, now looking at 667, again, I'm going to look at the ones place. I'm going to draw my 7 dots. Here are my 7 dots. Now you can see I have these guys all buddied up, but then this guy down here is by himself, which means that this number is not even, it's odd. Okay? Expanded form. Expanded form is when we take the number and then we write it as the sum of each of its place values. So looking at 676, I'm going to break this number down by place value. So in the hundreds place, I have a 6. A 6 in the hundreds place has a value of 600. I have a 7 in the tens place. A 7 in the tens place has a value of 70. And then again, that 6 in the ones place has a value of 6. So 600 plus 70 plus 6 equals 676. Using that same strategy, I'm going to do 667. 667 has a 6 in the hundreds place. A 6 in the hundreds place has a value of 600. It has a 6 in the tens place. A 6 in the tens place has a value of 60. And then a 7 in the ones place has a value of 7. So this answer gets us to 667. This part is the expanded form. Okay? Using my place value knowledge, I'm going to go ahead and answer these questions here. Okay? So these questions here ask me to use this number to do plus 100, minus 100, times 10, times 100, and times 1,000. And we're going to use that thinking about those zeros that I always tell you are so important in place value. So starting with plus 100, if I did 676 plus 100, the only digit that's going to change is my hundreds place, and it's going to change by 100. I told you that the 6 in the hundreds place has a value of 600. So if I add 100 to my 600, now I have 776. If I take 100 away from this 600, now I have 576. Okay? Times 10. 676 times 10 is 6,760. See how I added that single zero onto the end? Just like there's a single zero on the end of this 10 here. Okay, how many zeros am I going to add now when I do times 100? 2 zeros. So I have 6, 7, 6, 0, 0. And I'm going to put my comma between the 7 and the 6. 67,600. Now with times 1,000, I'm going to add these 3 zeros, 6, 7, 6, 0, 0, 0, and separate my periods here with my thousands period and my ones period. All right, using that same strategy, I'm going to quickly go through these guys over here. So plus 100 to 667. My hundreds place is going to go up by 100. 600 plus 100 is 700. These are going to stay the same, 67. Now my hundreds place is going to go down by 100. 600 minus 100 is 500. And now 67 times 10 means I'm going to add 1 0, 6, 6, 7, 0. So 6,670 times 100, 6, 6, 7, 0, 0, 66,700, and times 1,000, 6, 6, 7, 0, 0, 0, 667,000. Okay, now I'm going to compare the original two numbers, 676 and 667. Looking at the place values, I'm going to start with the hundreds place. My hundreds place has a value of 600. That's the same in both. Now looking at my tens place, this number has a value of 70 in the tens place, and this has a value of 60 in the tens place. So which one's bigger, 70 or 60? If you said 70, you're correct. So I'm going to circle this middle symbol. 676 is greater than 667. All right, still focusing on those same numbers. How many ones are in the tens place? So this question is a little bit tricky, but we can figure it out together. So looking at the tens place, normally I ask you how many tens are in the tens place, right? So in this question, I have 7 tens in the tens place. So how many ones are there in 7 tens? That would be the same as me showing you some blocks, and we have 7 tens, the big long orange pieces that we've used in the classroom, and there's 10 within each of these, right? So 10, 20, 30, 40, 50, 60, 70. How many ones? 70 ones are in the tens place. Now, how many tens are in the hundreds place? How many tens does it take to get to 100? 10 tens to get to 100. And I have 6 tens. So how many tens are there in the hundreds place? If you said, if you said 60 tens, you are correct. Using that same strategy over here, how many ones are in the tens place? There are 60 ones in the tens place. How many tens are in the hundreds place? There are also 60 tens in the 100s place. Okay, again, if any of this part of this front worksheet confused you or you're not sure how I got an answer, remember it's your responsibility to reach out to me and let me know which question you didn't get and how I can help you, and I'd be happy to do so. Okay, flipping the page over, we're going to look at questions 2 and 3 now, starting with question 2. It says, what is the value of the number 8? So the number 8 I see is in the ones place. So an 8 in the ones place has a value of 8. What's the value of the number 3? It's a 3 in the hundreds place. So what's its value? 300. Think about this like expanded form. If I wrote this number in expanded form, it would look like 300 plus 20 plus 8. the value of the ones place, the value of the tens place, the value of the hundreds place. Now I'm going to round. I'm going to round this number, 328, to the tens place. As a reminder, we underline the place we're rounding to, circle the digit next door, draw our bossy arrow over. What does 8 tell me to do to 2? If it's 5 or higher, we raise it up, so my 2 becomes a 3, and my bossy 8 becomes a 0. 328 rounded to the tens place is 330. Rounded to the thousands place is interesting because, as you can see, we do not have a thousands place. That's the same as if I showed you the number written this way, right? And normally this is not how we write numbers, but I always tell you to imagine there being a 0 in that thousands place. So we're going to go ahead and underline this one, circle my digit next door, draw my bossy arrow. What does 3 tell me to do to 0? Tells me to keep it the same. And then all my digits to the left or to the right get turned to 0 also. In this case, I'm not going to write 4 zeros, but you know that 328 rounded to the thousands place is 0. What do you think about the millions place? If I had showed you a million, it would look like this if I put those imaginary zeros in there. So I would underline the millions place, circle the digit next door, and what do you think is going to happen? If you said it rounds to 0, you're correct. All right, looking at number 3. Number 3 asks, is the number prime or composite? Now looking at number 17, I'm going to show you the 2 definitions of prime and composite numbers. So in your math book, in the back is our glossary. Here's the definition for a prime number. It says, a whole number with exactly 2 factors, 1 and itself. And here are some examples. They said 7 is a prime number, 13 is a prime number, and 19 is a prime number. Okay, these are not the only prime numbers, of course, just examples. Now a composite number, if I flip in my math book to the C section, composite number is here at the bottom. It says a whole number that has more than 2 factors. So an example is 12 is a composite number because its factors are 1, 2, 3, 4, 6, and 12. So going back to my question in mountain math, 17. If I wrote 17 and I asked you to list its factors, you would say 1 and 17. Can you think of a 2 times to get to 17? How about a 3, a 4, a 5, a 6? Are there any other numbers besides 1 and itself that are factors of 17? You're right, there aren't. So 17 is a prime number. Its only factors are 1 and itself. Okay? So I hope that you did well on your own, and I hope that if you had a couple that you missed, this video gave you a chance to fix them. If you'd like to pause this video and revise your questions 2 and 3, you can go ahead and do that now. Now I'm going to flip the page over and show you question 1 one more time, so you can pause the video there if you need to check any of your answers there. Here's question 1. There, that's better. Go ahead and pause this if you need to check any of these. And then I will see you again on May 8th to go over questions 4 and 5. Thank you. Hope this helped. See you later.